So why do we divide the nervous system into the central nervous system and the peripheral nervous system? Well, the central nervous system is the command center. It processes sensory input and takes that sensory input and then determines what motor output should occur as a result. It's so important to human survival that it's encased in bone. So we have the brain in the skull and the spinal cord in the vertebra. The brain's wiring is so dense and complex that growing a new neuron in the wrong spot is often considered more dangerous to the organism than the loss of that specific function. So to try and ensure stability within the brain, we have the oligodendrocytes, whose role, as you might remember, is to myelinate the axons to provide that insulation. But they also provide a substance called NOGO-A. They release that, and that inhibits the regrowth of axons. And the astrocytes, as you might remember, get involved in astrogliosis if there is cell damage or death, and that forms a glial scar to wall off any injury. So both of them restrict the growth of new neurons, but they do that for the reasons said, for the stability they provide. The peripheral nervous system, on the other hand, the flexible information highway, is the one that takes the information from the central nervous system and gives it out to the rest of the body, or receives information from the body and gives that back to the central nervous system. And because of the fact that it is connected throughout the entire body, there is no bony protection to it because it requires that flexibility to be able to move. But that obviously increases the risk of it injuring. But because it's got a simpler function and the requirement for higher flexibility, the system is prioritized for self-repair. And here, rather than the 4 glial cells that we have in the central nervous system, the astrocytes, the oligodendrocytes, the microglia, and the ependymal cells, here we only have 2. We have the Schwann cells and the satellite cells. Now, the satellite cells play part of the role of that the astrocytes would play in the central nervous system, helping to regulate that chemical environment that the other neurons survive within, taking nutrients in and removing toxins. But instead of having the astrocytes proper, oligodendrocytes, and even the microglia, instead we have the one Schwann cell that does a lot of this on its own. It is responsible for the myelination of the axon, but in the process of which it doesn't release NOGO-A, so therefore it allows for or doesn't restrict the growth of axons. It in itself also aids in the cleanup and the regeneration of dead or dying cells. So the reason why we divide them into 2, central and peripheral, is central because of the complex nature of what it does, needs to be protected in a very stable way. The peripheral, on the other hand, because of what it does and because of its extensive nature, there's a expectation that there's more likely for damage to occur, and therefore the system is designed to try to self-repair more easily.